cannot be factored, so it leaves it as negative 2x squared, and the bottom, x plus 5, x minus 5. So we have non-permissible values. X can't equal minus 5, and x can't equal positive 5. And those will be vertical asymptotes, because they do not cancel out. My hope is that by doing many of these, this is like this is the fourth example, but some of them have A and B. I hope you're starting to sort of get a feel for the steps. Like you're doing the same thing every time, which is kind of nice in that it's predictable, but it's also kind of nice because it's sort of like a surprise at the end. You don't know what graph you're going to get. It's like, when you're excited when you connected dots as a kid, you didn't know what the picture was, but the process was the same every single time. So here we go. Vertical asymptotes at x equals 5 and x equals negative 5. Next. Degree is the same on the top and the bottom. That's group 2. Horizontal asymptote at, look at the coefficients. Negative 2 in front of the x squared on the top. A 1 in front of the x squared on the bottom. Negative 2 over 1 is negative 2. So we can start drawing our graph.
Today, right?
Yes.
Okay.
Yeah, just. Okay, asymptotes at, was it 5 and negative 5?
Yes.
Oh, I have to listen. Whew. There we go. All right, 1, 2, 3, 4, 5. And 5. And then at negative 2. Oh, this is a fun graph. What weird things happen in this graph? Let's find our y-intercept. Plug in 0 for x. And we get 0 over negative 25, which is 0. X-intercept. Plug in 0 for y. And look at your fraction. When is the numerator 0? When x is 0. Oh my goodness, this is we found 2 points that end up being the same point. This is an example of where we have a point in the section, but we still actually don't know what's going to happen. Because you know how in the middle of your graph, you can go through your asymptote. It might still go through the asymptote. We don't know. We have 3 sections, no points in section 1. We have a point in section 2, but it's not helpful. And we have no points in section 3. So we're going to need to find some more points. Let's start in section 1. Do you see that plugging in negative 6 will be nice? And if I go to the original equation, wow, negative 72. This does not seem like a good start, but it's okay. And on the bottom, 36 minus 25, 11. Negative 72 over 11. Could you estimate that on your graph? Be negative 6 point something. 1, 2, 3, 4, 5. Here we go. Negative 6 point something. I'm going to label it right here. So negative 6 comma negative 72 over 11. And that is enough to say this section looks like this. And you see that 6 is going to be an easy one to do, mental math-wise, because it's squared on the top and squared on the bottom. So negative 6 squared and 6 squared will be exactly the same thing. So 72 over 11, hey, that's a point over here. In section 3, that section's done. So getting a point in a section usually figures out a lot of stuff for you. In the middle, I might plug in like close to the asymptote because I want to know, does it go down or does it go up? I might plug in 4. And if I plug in 4, back to the original, I'm going to get negative 32 on the top, 16 minus 9, negative 9 on the bottom. Negative over a negative is positive, so positive 32 over 9, which is going to be 3 point something, 3.5 repeated. 4 comma 3.5 repeated, if I label that. This section has to go up. It can't hit that button and then go back down because then we would introduce another x-intercept. And because of symmetry, are you okay that negative 4 will do the same thing? Yes.
Does it only happen with the difference of squares being a denominator?
That it's symmetrical like this?
Yeah.
It only happens if you have x squared over x squared, because it doesn't matter if you put it in positive or negative. So as long as there's an x squared on the top, x squared on the bottom, no other x's, then it's going to be symmetrical, because plugging in 4 does the same thing as plugging in negative 4. If I had a plus x on the bottom, then it would mess things up again. You'd have to check and see what happens. Something to notice. Do you notice in this rational graph that we have a bounce at x equals 0? Do you notice in your original equation that that has a multiplicity of 2? So some connections with some of our other units that we've had. So whether it's going to go straight through your x-intercept or bounce seems to follow those same ideas and those same rules. Okay?
Questions?
Domain and range. If you wanted to do the domain of this one, you could say x can equal negative 5 and x can equal 5. That would be your domain. The range is kind of cool, sorry. It's kind of weird. It goes from negative infinity, I'm going to do this in interval notation, starts at the bottom, negative infinity up to negative 2, round bracket, because negative 2 is not included. Then it starts again at 0, and 0 is included, and goes up forever to infinity. So that is a little bit of a strange range.
And how would one do this in the other notation type?
What's that?
How would one do this in the other notation type?
In the other notation, you would write
Could grade
y
9 student
is less
council
than
please
negative
report
2,
to the office?
or
That's grade 9
y
student council,
is
please report
bigger
to
than
the
or
office.
equal to 0. Okay, questions for practice on this one? Just number 4. I sure hope there's an A and B in all of these.
There is.
There we go, then it's still questions. Whew.
Good luck.